have the exact same thing. So when I come back from my break, I'm taking a retake of a team test,
Uh-huh.
and that thing that I sent you on our last meeting, it's pretty much the exact same thing, but with just different questions on it. So I will send you a picture of it now.
Okay. I was gonna say I'm sure I can find the last one. But if you've got something more current, by all means, send that. Yeah, I do actually have the last one. Um, but it's just kind of a word problem, couple of word problems.
Yeah.
So if you have anything more current, that would be better.
Um. Yeah. I'll send you a picture of this back page here.
I don't remember if we got through all three of these problems or not. Did we?
Yeah,
I
we
don't
did.
remember doing 2B.
Let me look. No, we did it because we had to move the x
Yeah,
plus
you're
3 to the
right.
other side.
You're right.
Yeah.
Exactly right. Okay, so we did that one. So send me something new.
Okay.
Tell me when it's been sent.
Are you able to write down your email again?
Yeah. Here, let me do it real quick. Can you read that?
Yeah.
It's always the one you want to send it to. I've got a couple email addresses, but this one gets to me the quickest.
All right. I think it's sent.
Okay. Go have a look. It's got to say file sent on your end. Okay, I got it. Let's see. I think this would be better if I download it. No, I gotta figure out this system. It's not quite what I hoped it would be. Um, let's see. I think I have to click on the email. Let's see. This has one problem. That's good enough. That's the only problem on this page?
Yeah.
All right. Gloria is weighing combinations of geometric solids. She found that 4 cylinders and 5 prisms weigh 32 ounces and that 8 prisms and 1 cylinder weigh 35 ounces. Write and solve a system of equations to determine the weight of each cylinder and prism. Define your variables. Notice that last sentence. Always the most important sentence in a word problem is the last sentence.
Mm-hmm.
It tells you exactly how to start the problem. Define your variables. So let's start with that. What two things are they asking about? And the way you define your variables, actually, normally that sentence is not there.
Uh-huh.
Usually the last sentence is write and solve a system of equations to determine the weight of each cylinder and prism.
Mm.
So define your variables.
So
How about this? About C equals the weight of each cylinder.
yeah.
In other words, you don't have to use X and Y.
Mm.
You can use letters that, what should we use for the prisms?
P.
Now, do I have to spell it out like this? And the answer is yes.
Mm.
Because a lot of times it can be the number of P's or the price of P's or lots of different things. So it really is useful to spell it out. Know exactly what your variables mean. That's why it tells you that right there. Define your variables. That
Mm.
is always the first step in any word problem. Okay, so now let's go back to the beginning. In other words, you always start at the end to define your variables.
Yeah.
Whatever they're asking for, those are the variables. Now, she found that 4 cylinders and 5 prisms weigh 32 ounces. Give me an equation that says that.
So
In other words, the secret of word problems is defining your variables and then translating the word problem to an equation.
okay, so 4 would it be like 4C equals
Uh-uh.
30
4C and.
oh yeah, plus 5P equal 32 ounces.
There you go. Now, we can't solve that because that's 2 variables and only
Mm.
1 equation. So, if we can get another equation, we'll be in good shape.
Yeah.
Well, what's the next equation?
So 8P plus 1C equals 35 ounces.
Now, notice I wrote that backwards.
Yeah.
It's because I wanted to put it in standard format. When
Yeah.
you have 2 equations and 2 unknowns, it's real easy to solve them.
Mm.
But it helps if you put them where the C's are together and the P's are together. Now, you have various methods that you've learned for solving 2 equations and 2 unknowns. There is equation 1, there's equation 2. What are the 2 methods?
Would it be elimination
And,
and substitution?
okay, good. What are we going to use here?
Would you use elimination?
Yeah, whenever both equations are in standard format, like this,
Mhm.
elimination, I always use it. Okay, you don't have to. You could use substitution, but then you'd have to algebraically manipulate one of the equations and
Yeah.
then use substitution. So elimination just ends up being the easiest. Okay, so how are we going to eliminate one of these variables?
Um, don't you put it to like
You got 2
what they?
choices. You can add or you can subtract the 2 equations. Now, neither one of those eliminates a variable, correct?
Yeah.
But what if I multiplied one of the equations by a certain number and then added? In other words, algebra says you can do anything to the left side of an equation as long as you do it to the right.
Uh,
So let's look at equation 2. What should I do to that equation?
um. Well, you could multiply the one
By what?
and get by one,
Now you got to
and that would
multiply
like
by minus 4. Notice what that's going to give you. It's going to give you a minus 4c.
Oh, yeah.
And then when we add the two equations together, c is going to be eliminated.
Yeah.
That's the key. That's why they call it elimination, is because you want to eliminate one of the variables. Well, I can't multiply the left side by minus 4 unless I multiply the right side by minus 4.
Yeah.
First rule of algebra. So the way I like to do this is I like to label my two equations, and then when I manipulate one of them, I just call it, that's the new equation 2. So what's the new equation 2?
So it'd be
Yeah.
negative 4c plus
Minus times a plus is not a plus.
oh yeah, it's a minus, yeah. So a negative 48.
No, 4 times 8 is 32.
Oh yeah, 32, my bad.
And this one, you can use a calculator, but it's minus 140. Okay?
All right.
In other words, I've got to multiply the right side of the equation by minus 4 also.
Yeah.
So what I normally do is run a line through that so I don't get confused. And now I've got these two equations. Now, what do I have to do to eliminate a variable? What can I eliminate?
You can eliminate the 4c's.
By doing what? It's important that you understand what you're doing when you eliminate the 4c's.
Are you just...
You're adding the two equations. Just put a big old fat addition sign right there.
Okay.
Okay, now add 4c to minus 4c. What do you get?
You just get... Well, it's like 0.
Exactly. That eliminates the variable c. And now add 5p to minus 32p. What do you get?
You get 27 or negative 27.
Negative 27p. And now on the other side, you're adding 32 to minus 140.
Minus 108.
Now finish solving that problem, that algebra equation. What's p equal to?
So you would just divide negative 27, right? From both sides? Or well, you would add 0 first, but...
No, the 0 goes away. You don't need to pay any attention to that. How do you solve that equation? Minus 27p equals minus 108.
Wouldn't you would just divide the negative 27 by the p, or well, you would divide it from the p.
Yeah, you're not wording it correctly, but this is what you mean.
Yeah.
You divide both sides of the equation by minus 27. Now let's go over that a little bit. Why are you doing that?
It's to get p by itself.
Well, the minus 27 originally is a multiplier, right? It's multiplying the p. So I've got to do the opposite of whatever it's doing. And the opposite of multiplication is division. So in order to get rid, I know I want my final line to be p equals something. So I got to get rid of everything else. And to get rid of the minus 27, I just divide both sides by minus 27. What's that make p equal? You can use a calculator if you want.
Would it be negative 4?
Nope. You got a negative divided by a negative.
Oh, positive 4, yeah.
Okay. The first thing, when you're doing multiplication or division, the first thing you want is the sign. Forget about the number. Get the sign right. You'll need the number also, but if you get the sign wrong, you're getting the problem wrong.
Yeah.
So the sign is absolutely critical. Okay? So P equals 4. That means I have 4 prisms.
Mm.
Now how do I figure out the, excuse me. Yeah, no, P is the weight of each prism. So the weight of each prism weighs 4 ounces. Now, how do I figure out the weight of each cylinder?
Do you just plug P in so you would plug 4 in for every P?
Into which equation? I'm looking at 3 equations, one of which has been marked out.
Um, doesn't it not matter? You can do one or the new
You're
2.
correct. You're absolutely correct. You can use any of the 3 equations you're looking at. However,
Mm.
let's use the one with the smallest numbers because that results in the highest accuracy of our arithmetic.
Okay.
So for our example, let's use that one. So
Yeah.
I've got 4c plus 5p equals 32. And I'm going to plug in p of 4. So that means 4c plus 5 times 4 equals 32. That
Mm.
means 4c equals 12 and c equals 3. So there you go.
Mm.
The cylinders weigh 3 ounces each. The prisms weigh 4 ounces each.
Yeah.
And that's pretty much the way you do a word problem. Every word problem, I want you to start at the end, the
Okay.
last sentence.
Yeah.
Now, I can't quite say that here because they add an awful lot of last sentences. In other words,
Mm.
normally this is the last sentence. Write and solve a system of equations to determine the weight of each cylinder and prism. This is
Yeah.
the important part of the last sentence. The weight of each cylinder and prism. That tells you exactly how to define your variables.
Yeah.
Well, cylinders should be the weight of each cylinder and P should be the weight of each prism. So basically whatever they're asking for is how you define your variables. Now, once you get those 2 variables defined, you can go back and start at sentence 1 and start writing equations. And almost all of these word problems are designed so that you end up with 2 equations and 2 unknowns.
Mm-hmm.
All right, what else you got?
Well, should we do the other practice thing? Like, it's almost the exact same, but just different, like, questions.
Matt, here's the problem I have as a math tutor. I'm not sitting in on your class, so I don't
Mm.
know what you're working on exactly. I need you to tell me what to do, not the other way around.
Okay.
Okay? If you still
Yeah.
have some questions about how to solve word problems like that, then by all means, let's do another one.
Okay.
That's always the best thing to do. Once you get totally convinced that you know how to do it, then we don't need to waste any more time doing it.
Okay.
You need to go on to the next topic. But until you are perfectly comfortable with knowing that you know how to do it, let's keep doing those kind of problems.
Okay.
And this time your phone should have my email address. So
Yep.
just type DA. That's all you need to type. And again, let me know. Are you using an Apple?
Yeah.
And are you attaching it as a large image file?
Yeah.
Okay, good. And tell me when your cell phone says file sent. In other words, it's not going to show up on my end until it says file sent.
Said file sent.
Okay. My computer is running a little slow. Hold on. There it is. Okay, this should work. All right. Let's see if we can read this. I think I can read it. You've got a copy in front of you, so you should be able to read it. Okay, the grasshopper is working on her hops. She's trying to jump as high and as far as she can. Her best jump so far is 28 centimeters, and she reached a height of 20 centimeters. Sketch the graph, include significant points, and write an equation of the parabola that describes the path of her jump. First of all, whether it's a grasshopper jumping, or if you go out in your backyard and you throw a baseball, or if you hit a golf ball, any parabolic motion follows a quadratic. Okay?
Yep.
So the formula for a quadratic is what we need to start with. Hold on a second. Okay. So y equals a times x minus h squared plus k. That is the vertex format of a quadratic.
Yeah.
Vertex format. Now, the reason that's such a great form, there's like 3 different formats, but the reason vertex format is so great is that it tells you exactly where the vertex is.
Mm-hmm.
Okay? So if I want to draw a graph, here's where she starts. She jumps and she comes down there, right?
Yeah.
In other words, any parabolic motion is a parabola. So you can draw a perfect parabola. Well, what did it say? It said she's trying to jump as high, and she jumps 20 centimeters high.
Mm-hmm.
And she jumps 28 centimeters long. Now, why did I draw the parabola like that? It's because I wanted the origin of my axis to be at one of the key points. And so I made it her starting point, the grasshopper's starting point. I could have just as easily made the vertex at the origin, but this works just as well. Okay? So the thing is to take your picture of her jump and put it on an XY plane. Okay?
Yeah.
There's X, there's Y. We know it's going to follow a parabolic motion. Anything that has to do with planet Earth follows a parabolic motion. Doesn't matter if you're throwing a baseball or a grasshopper is jumping.
Yeah.
Now, tell me what that point is right there.
That's your vertex. So it'd be 1420.
Now tell me everything you can tell me about this equation.
The vertex is the H and K, right?
Correct.
So, you have A times 28.
Oh, it's X minus, what's the X coordinate of the vertex?
Oh, 14. And then squared plus 20.
Okay. So we know that much about this equation of motion. Now we have to solve for A. So in order to solve for A, we merely need to find one other point on that graph. Okay?
Yeah.
How about this point there? What's the x and y coordinate of that point?
0, 0.
Okay, so I'm going to plug in 0 for y and 0 for x. Okay, so in other words, every point on my graph over here has to satisfy this equation.
Yeah.
So I can pick any point I want, plug it in, and that's going to allow me to solve for A. So when y equals 0, x is equal to 0. And now if I do that math, I get 14 squared is what? You have a calculator in front of you? Here. I think it's 268. No. 196.
Yeah.
So it's 196A. I'm going to write it in the normal way we write that, with the coefficient in front, plus 20. Now I can solve for A. How do I solve for A?
You subtract 20 from both sides, and then you divide 196 from both sides.
So A is equal to, and if I'm trying to simplify that, the way I simplify it is I first of all notice that I'm looking at two even numbers, so I can definitely cut each one of them in half. And I'm still looking at two even numbers. I can still cut each one of them in half. And that is my final answer. I cannot simplify that anymore. So I figured out what A is. What's my final equation? Their question is write the equation and sketch the graph.
So the equation would be y equals -5/49 times x plus 14
Minus 14, right there.
minus 14 squared plus 20.
There you go. In other words, my final equation always has the x and the y in it.
Yeah.
But it solves for everything else. In other words, you no longer have the h, you no longer have the k. Those are replaced by numbers, and the a is replaced by numbers. So this equation over here on the lower right describes the motion of that grasshopper. It doesn't matter what x you want to pick. Let's say you pick an x of 2. Well, what would its height be? Well, you plug in 2 for x and you figure out what y is. So this is the equation of that motion at all times. All right. Let's look at number 2 here. Complete the square. All right. Completing the square. I'm going to start up here just so I have more room to write. What we're trying to do when we complete the square is we're trying to put it in this format right here. Remember the vertex format?
Yeah.
Okay. Well, we're going to take this equation and try to make it look like this equation.
All right.
Okay. Now the way you do that is you kind of separate the x and the x terms. So I'm going to do it like this. X squared plus 4x. I'm going to put a parentheses around them, but I'm going to leave some room. Now, when you're completing the square, the one question you need to ask yourself as you go from one line to the next, have I changed the equation? Have I changed this equation?
No.
Okay. Now let's complete the square. You always complete the square inside the parentheses. Because all I've done is add parentheses around the 2x terms.
Yeah.
I've allowed some space to complete the square. Well, the way you complete the square is you take half of the coefficient of the x term and you square it and you add it. Very simple. So what number do I need to write in there?
4.
Plus 4. It's always a plus. Okay. Now I just changed the value of that.
Yeah.
I've changed it. So what do I have to do to make sure I have not changed the equation?
You have to subtract 4
From the
to the
same
right
side.
side. Yeah.
Right.
Well, it's to the left.
It was on the other side, and it will be when you get a little bit higher math. Sometimes that number will be on the other side. You just have to make sure you haven't changed the equation.
Yeah.
Okay. So I can take this plus 1 and minus 4 and combine it to be minus 3. Still have not changed the equation. You check this equation with this equation, it's the same. The thing is that because I have completed the square, I can now write that as a linear term squared every time. That's why you complete the square, is so that you can write it in this format. Well, what is x squared plus 4x plus 4? It's always x plus whatever I got when I took half of that.
Oh, okay. So, yeah.
In other words, x plus 2 squared is that. Still have the minus 3. Now, notice what I'm looking at. I'm looking at that format perfectly.
Yeah.
Where's the vertex?
The vertex is at 2, right? Or well.
It's at negative 2.
Yeah, negative 2.
It's always the negative. Remember, this is x minus h.
Oh, yeah.
So
yeah.
if this reads x plus 2, then h has to be minus 2. And the y coordinate?
Plus 3.
Minus 3. This is a plus k.
Oh, okay.
So the most important part of this whole problem is this formula right there. You cannot do the problem if you don't start with that.
Yeah.
And that tends to be the case with almost all math, is that the way you want to start virtually every single problem is, what's the general formula? Once you know the general formula, then you try to make your equation look like that formula. And that's what we did. And we had to do it by completing the square. But notice how similar that looks. A is 1. H is minus 2. K is minus 3.
Yeah.
So immediately we know where the vertex is. Now, let me read these directions again. Complete the square of the following. We did that. Put it in graphing vertex format. We did that. This is vertex format. Then find the x and y intercepts. All right. Let me erase some of this stuff so I have room to maneuver. There's our equation at the bottom.
Yep.
Where do I find and let's make that a y. That really is a y.
Yeah.
Okay. Now, when I find the y-intercept, how do I do that? It wants the x and the y intercepts. What's x? When I am on the y-axis, what is x?
0.
Okay, plug in 0 for x, give me a number.
So, like, solve for it?
Plug in 0 for x.
Okay.
And what do you get for y?
So you would get -1
You get
or
4
1.
minus 3. You get positive 1.
Yeah.
Okay, now the x-intercept is where y equals 0.
Mhm.
So I'm going to plug in 0 for y, and then I'm going to solve that.
So would you just want to get x by itself first, or you would just solve?
Yeah, this is a little tricky. Let me see if I can make some room here. Unfortunately. Okay. Trying to remember what the equation was. What was it? It was x minus 2 squared?
It was x plus 2, I think.
Yes, you're absolutely right. Plus 2 squared minus
3.
3 equals y. Okay? So when I solve for the y-intercept, I made x 0 and I got 1. When I solve for the x-intercept, I'm going to make y 0. And you're right, you're trying to isolate x. There's actually two ways to do it. You could expand that and end up with a standard quadratic and then try to factor it, or use the quadratic formula. But there's actually a little easier way to do this. It's where you take the square root of both sides. Okay? The first
Mhm.
thing I'm going to do is move the 3 over, like that. You with me?
Yep.
Now I'm going to take the square root of both sides, so x plus 2, I'm going to take the square root of that and square root of that. What's x
Mhm.
plus 2 equal to?
Uh, I don't know what the square root of 3 is.
Well, you don't need to know. That is the answer.
Oh, okay.
However, it's plus or minus the square root of 3. In other words, I'm not interested in converting that to a decimal.
Uh-huh.
Square root of 3 is an irrational number. It's also the most exact answer you can have.
Yeah.
So you're getting to a point in algebra where they don't want you to convert to decimals anymore.
Okay.
They want you to leave all your answers in radical format. That's the perfect format.
Mhm.
However, the biggest mistake most of my students make is that when they solve an equation by taking the square root of both sides, like we did, they forget the plus and the minus. Always.
Uh,
99% of them forget it. I forget it half the time.
yeah.
So you kind of have to just keep in mind that when you are solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus.
Okay.
That's just
Yeah.
the only way I know how to say it.
Yeah.
I don't know how else to put it. Okay, now solve that for x.
Um, so you would just subtract 2.
Give me the answer.
X equals plus or minus the square root of 3 minus 2.
Yeah. Only thing is that's not the way we generally look at it. We
Mm,
generally have this as the answer. And notice that it's the same thing.
yeah.
The difference is that this is what the answer when you're using the quadratic formula always looks like. You have the
Okay.
whole number first, and then you have the radical number after the plus and minus.
Yeah.
So when we get an answer that is a quadratic formula kind of answer, let's put it in the quadratic formula. You would not lose points if you gave that answer.
Yeah.
You'd get it right. But just from a point of mathematics, let's try to make it look like it came from the quadratic formula. In other words, remember the quadratic formula is minus b plus or minus the square root of stuff.
Mhm.
That's what this looks like. This up here is backwards. It's got the a squared plus or minus first and the minus 2 second. So that's the only reason I switched them around.
Okay.
But we got everything. We got our x and y intercepts. Those are the two x-intercepts, incidentally.
Yeah.
You don't have just one x and y intercept.
Yeah.
First of all, you have a, let's see, what did we get? -2, -3. So here's our vertex. We know it opens up. Well, there's only one y-intercept. We figured that one out.
Yep.
But there are two x-intercepts.
Yeah.
What are they? One of them is -2 plus square root of 3. That's this one. And the other one is -2 minus square root of 3. And that's that one. So we figured out the vertex. That is -2 -3. So we know everything there is to know about that parabola. We know its vertex and we know its x-intercepts. 3 points is all it takes to define a parabola, a quadratic. So once you have 3 points, there's no point in really doing any more work. Some teachers will ask for 5 points, which is silly. It's like asking for 3 points on a straight line. 2 points define a straight line. You don't need 3 points. Okay? All right, let's look at B. Same thing. Complete the square and do everything, find the vertex, graph it, and find the x and y intercepts.
Yeah.
What's the first thing we should do?
You want to get everything over by the x squared.
And we want to leave that coefficient positive, so we want to move everything to the left, not to the right. So if I just solve that equation, I get that. Okay. Remember this, I'm going to write vertex format out again because they specifically said they wanted it in vertex format.
Yeah.
Now, we can replace that 0 with the y. Okay. But let's complete the square. What's the first step in completing the square?
You want to put the parentheses around both of the x's and leave a space.
Perfect. Let me rewrite it. X squared plus 8x, leave the space. Still got the plus 11. Now what?
And then you want to find, so half of 8, so 4, and then square root it.
Not square root it, square it.
Or square it, and then so it would be plus 8.
No? What's 4 squared?
Oh, 16.
Okay, so I'm going to add 16, which means I have to do what to balance it out?
You want to subtract 16 from the plus 11.
Okay, so now that is exactly the same as that.
Yeah.
The only difference is I can write it a little differently. I can write this whole term as a linear term squared. What is it? X, it's plus, it's whatever that sign is there. What goes
plus
with it?
4.
4. It's whatever we got when we took half of 8.
Yeah.
And it's squared. In other words, x plus 4 squared is that right there. Okay, combine those two, you get -5. I now have it in perfect vertex format.
Yep.
What's the vertex? What's 8?
-4 and -5.
Perfect. Okay, so let me erase some of this stuff so I have room to write. So I'm 3/4 of the way to being able to graph it, right? In other words, the moment I get it in vertex format, well, that means my vertex is -4, -5 right there. Does it open up or down?
Up.
Okay? So I basically can draw the graph. The only thing I'm not positive of is, do I have the two x-intercepts correct? And do I have the y-intercept correct?
Mm.
So let's do the easy one first, which is the y-intercept. Now, this says 0, but I can also make it y. That is the function.
Mm.
It's y equal this whole thing on the left. So the y-intercept is what?
So x would be 0,
Okay.
and then 16 minus 5, so 11.
Okay. Now what's the x-intercept?
Um,
In other words, that's 11.
yeah.
It is 0, comma 11, despite how I've drawn it.
Mm.
Okay, it's not so much. After I figure out the y-intercept and the x-intercepts, I'll redraw it so that it's more accurate.
Okay.
How do I get the x-intercept? What do I make y?
You make y 0.
Okay, so let's go back here. Make y 0 and solve that equation, and that will give us our two x-intercepts. And you almost always do have two x-intercepts when you have a parabola. You can see
Yeah.
that this thing crosses the x-axis twice.
Uh,
It only crosses the y-axis once, ever.
yeah.
Okay? So how do I solve that now?
Okay, so wouldn't you put the plus 5?
Okay, next step.
And then you would square root both sides?
Okay, tell me what this is equal to.
Um, the square root of, or plus or minus the square root of 5?
Good. Making sure you didn't forget the plus or minus.
Yeah.
And one reason you should always remember it is because you know you got two solutions.
Yeah.
So the only way I get two solutions out of this is if I have a plus or minus.
Yeah.
So what are the two solutions?
So you would have negative 4 plus 5, or plus the square root of 5,
Yeah.
and then negative 4
I'm
minus
glad
the
you said it like that. That shows me that you know what it means.
Yeah.
But we can write it. Since I ran out of space, I wrote it all as one. But
Mm.
that is two solutions. It's negative 4
Yeah.
plus the square root of 5, and it's negative 4 minus the square root of 5.
Mm.
Okay? So let's redraw everything. Because that's really what they wanted us to do, was to graph it. Start with our vertex, minus 4 minus 5. I know it opens up. Let's see, minus 4 plus 2.2 is about minus 1.8. Call that right there. And minus 4 minus approximately 2.2 is minus 6.2. Call that there. Now we have our 3 points that we just have to connect with a parabola. And notice that our y is indeed at 11.
Yep.
So everything looks good. We got a vertex at minus 4 minus 5. We got both x-intercepts. And if I wanted to write these, here's the way I would write it. Minus 4 minus root 5. And this one over here would be minus 4 plus root 5.
Yeah.
In other words, I would not convert it to a decimal. This is the proper mathematical way to write it. This is an exact answer. Any other answer you give is not going to be exact. It's going to be an approximation.
Yeah.
So like I said, when you get to Algebra 2, they start wanting exact answers. Okay, so the exact answers for the x-intercepts are those two right there. All right, so that's the way you do those, completing the square. Now, we got 10 minutes here, and it looks like you're out of problems.
Yeah.
I'll give you a slightly tougher one. Complete the square on this. Tell me how you're going to do it.
So you would put the parentheses around both x's and leave a space.
Now, here's the thing I haven't told you, is that you cannot complete the square as long as this number is not 1. That number has to be 1. You cannot, if it's 2, you can't do it. If it's 3, you can't do it. If it's 1.1, you can't do it. So in order to complete the square, you have to make that number 1. How am I going to do that?
You would just subtract 1?
Not subtract. I would factor a 2 out. In other words, isn't this the same thing?
Yeah.
That's how you do it.
Okay.
Okay. And now complete the square inside the parentheses.
So you would plus 2.
Oh, what's half of 2?
1.
Square 1?
Oh, 1.
So it's plus 1. But when I do that, how much did I add to the left side of the equation?
You added 1, right?
Well, no, that 1 is being multiplied by this 2.
Oh, yeah.
So I really added 2.
Yeah.
So I got to subtract 2. That's the trick. That's why I wanted to show you the problem. Is if you're completing the square and the x squared term does not have a 1 as its coefficient, you have to factor it out.
Yeah.
And even if it doesn't factor nicely, let's make that a 3. Okay?
Okay.
Well, I still got to factor out the 2, but what I'm left with is that, right?
Yeah.
Okay, now take half of that and square it. Well, half of that is 3/4.
3/4.
Okay, squaring 3/4 is 9/16. Now, how do I balance it? I just wrote in 9/16. You can't add a number to the left side of the equation arbitrarily.
Yeah, so you'd have to subtract that.
Subtract what?
Well, wouldn't you do the 9/16 times 2?
Which is, yes, you would. What is that?
Would it be 1836?
Yeah, you just multiply numerators only. Think of that 2 as being 2 over 1.
Okay.
I multiply numerators, multiply denominators, that's 18/16. So I'm going to subtract 18/16. And that's how you do those.
Okay.
Now, the way I would write this in the final format would be 2 times x minus, what was half of that? 3/4 squared. And this looks like negative 1 1/8. So that would become 8 7/8. So there is my new equation after completing the square. And the beauty of this format is I know what A is, I know what H is, and I know what K is. So I know where the vertex is. That's the usual reason you're completing the square. So you'll immediately know where the vertex is. And then this is just a vertical stretch factor. So instead of a parabola like this, it's a skinnier parabola like that.
Okay.
Okay. But so this too definitely affects the shape of the graph, but it more importantly changes the way you complete the square.
Yeah.
If this number is not 1, you always have to factor it out, even if it doesn't factor nicely. In
Uh-huh.
other words, I had to factor it out even if that was a 3. It just makes that 3 halves. 3 halves times 2 is 3. So I haven't changed anything. And then you have to take half of that, square it to get that, and then multiply that by the thing you factored out to get that.
Mm.
So this is the most complicated you'll see. And
Yeah.
they may not have even given you one like this. I don't know. But
Yeah.
I wanted to give it to you just so that if they do give it to you, you'll know how to handle it. And
Yeah.
whenever you're talking about completing the square, that's an important part of it, is being able to factor out that lead coefficient.
Mm.
Okay? All right. Matt, I am going to let you go.
All right.
And we'll chat, I think, tomorrow? No. You got another
I
appointment scheduled here soon. It's on Thursday.
Yeah.
Thursday at 2:30.
Yep.
Okay. So what I'm going to do Thursday, Matt, this phone number that I called you originally on today, is
Uh-huh.
that yours?
Yeah, it is.
I will text you the meeting ID number. I won't call you.
Okay. All right.
In other words, after the first session, that's the way I usually deal with it, is just texting the meeting ID number.
Okay.
Okay, and you know how to find the program. Go to meeting. You should have an icon on your desktop.
Yep.
Okay, I'll talk to you Thursday at 2:30.
All right.
All right, Matt. Bye-bye.
Thank you.